Okay, cool. So first thing I'd like to talk about is these three homework assignments: mode, pattern array, balance brackets. How did these seem to everybody?
Yeah, the balance bracket.
It's a toughie, right? We'll get to that one, but I'd like to start with mode first. So I'm going to open that up real quick. I believe I have it here. Calculate mode. So I don't know if we'll have time to do all of these assignments in both JavaScript and Python. So do any people have a preference over which one we do? Python? Okay. It's the first one I heard, so that's what I'm going with. All right, so calculate mode. Let's take a look at the actual README for that. Make sure we understand the problem before we dive into it. Okay, so this seems like a pretty simple. It says calculate mode. It takes in an array. So we'll take a list of numbers or strings as input and return a list of the most frequently occurring values. If there's only one most frequent value, it returns a single element list. So the examples they have, 1, 2, 3, 3, returns an array with just 3 in it because 3 is the most commonly occurring one. 1, 2, 3 returns 1, 2, 3 because they all occur with equal frequency. All right, so is any confusion there about what we're actually trying to accomplish?
Yeah, I was actually confused on this because I was wondering, like, what happens if it was like 1, 2, 2, 3, 3, 3? Does it just return 3, or would it return 2, 3?
Sorry, it has what numbers again?
Like 1, 2, 2, 3, 3, 3.
So it has 1, 1, 2 2s, and 3 3s?
Yeah.
So in that list example you gave, 1, 2, 2, 3, 3, 3, what is the most commonly occurring element there?
Could be 3.
Yeah, that's the answer we're looking for.
Oh, okay. That's where I was kind of confused with. Okay.
Yep. So I'm going to actually copy these examples so we know what we're looking for. And actually, we can use these as the basis for our unit tests. So I'm just going to write down the examples here and comment them out. And you know, while we're at it, let's do this the object-oriented way. Let's write some unit tests. So first off, I'm going to make sure that I have access to my calculate mode function. So I could say from calculate mode with an underscore, import calculate mode. And then we're going to also import unit test. All right, so to set it up, I have to first set up a class. And I'll call this class, I'll call it, what is it? Calculate mode unit test. And that, it always says unit test dot test case is the word I was thinking of. I'll call this test case, not unit test. And then I'm going to do this thing that says if dunder name dunder equals dunder main dunder. Then we write unit test.main. So that's the thing that tells it to run only if we run calculate mode spec.py directly. All right, and then we can get some test cases going. So anyone have I'm naming things is actually it's one of those skills that comes with practice and it's very underrated. So what should we name our first test?
Test number 1.
Well, is that very descriptive? We could name it test number 1. Is that very descriptive?
No. We'll write it as test underscore check input.
Mm-hmm. Check input. So I would like to test. So what I'm thinking is I would like to test different ways that this could play out. So for example, I want to test if there's just one most commonly occurring element. So like test single most common element, which always takes self as an argument. And the things I'm thinking of here, looking at my examples, I've got 1, 2, 3, 3, and 4.5, 0, 0, 1.5, negative 1, 1, 1.5. All of these should return just one number. So that's the kind of the theme I'm going for this test, this particular one. So I could say like this, self.assert equal. And it would be calculate mode. Oops, get that wrong. An array of 1, 2, 3, and 3. And I expect that to be an array with just 3. So fun fact, you can have multiple assert equal statements in one test. And I like doing that sometimes because I'm essentially just grouping all of these different versions into one test case of.
There's still just a single element array expecting back.
Exactly. Just gonna copy this line.
So why are our classes not in snake case?
I'm sorry, say it again.
Our class, why do we not have it in snake case like everything else is in snake case? Is there an obvious
Good question. I'm not entirely sure. I feel like that's a convention thing, or maybe I'm doing it wrong.
I think that's just a convention. Test cases are written in classes.
Yeah.
I didn't see it in snake case.
Yeah, I'm not sure.
Like from a class, like
Mhm.
class, I've never seen a snake case.
Yeah. And again, whether you're doing snake case or camel case, the only thing is just it's convention, and it's never going to change. Like, except with the exception of things like class, like with file names, it's rarely going to actually affect how your code actually runs. All right, so we've got two things there for if there's one common element. Let's see if there's one for if there are two answers, like in 1, 1, 2, 2. So I'm going to test two most common elements. Got the colon, there we go. So you can see we have a lot of different asserts here that we can use, but assert equal, you can rarely go wrong with that one because, I mean, that's the easiest way to do things. But I do encourage you to look at the documentation for unit tests because there's a lot of different ways to test your code and check different aspects of it. So expect this one to be 1 and 2.
Change one to two.
Yeah, you gotta change 1 to 2.
Oh.
Number 1.
Thank you. I'm going to write one more test, and I'm going to write, this one's going to be if there is no most common element, if every element recurs with equal frequency, like in 1, 2, and 3. So I'll say test, well, I'll call this one, all elements equally common. Okay. Any questions on how I set up my unit tests here? Remote, any questions? All right, cool. Remote. Okay, I think we're good. All right, so now we have some tests. We know what we're looking for. And now that we know what we're looking for, we can start writing some code to pass that. And actually, before I do that, let's try running our code to see if it works. So I should be able to say Python calculate mode spec. Uh-oh. Oh, okay. So if we look at our error, it says file calculate mode spec line 2 from calculate mode import calculate mode and tells us exactly where to look. We had a problem def calculate mode. So the problem is here. And of course, is you can't have a colon followed by nothing. If even I just put the word pass there, which is just a kind of a placeholder, that should fix that error so it actually runs the tests. In this case, it says calculate mode, all the tests ended in errors because we gave calculate mode one argument, but right now it's set up to not take any. So let's fix that. Now it takes an array. Actually, let's run it with the green command. I forgot about that. Makes it look prettier. There we go. So now we have 3 failures, which is different than 3 errors. So we look at the failures. It says, assertion error, none does not equal 1, 2, 3. So it returned none when it was expecting this array. So now we need to actually make sure it returns the arrays. So let's pseudocode this problem out now. So we have a function, calculate mode. Takes an array. What's step 2?
So we need to find a way how we could create a dictionary for every item in the array. We could log the item in the dictionary, and when the with value of 1, and when that item comes up again, we could increase the value by 1 increment.
Okay, so we can use a dictionary to keep track. So what Pavel was saying is that we can use a dictionary to keep track of how common things occur. So we add an element as a key to the dictionary, and the value will be how many times that element has occurred. So let's break that down into smaller steps. So I'm first going to define an empty dictionary. All right, so we have an empty dictionary. What's the next step in that solution?
So if it is already in the dictionary,
If what is?
the number that is already in the dictionary, then we just increase the value to that number by 1. If it is not present in the dictionary, then we just create a new key value there and set it up.
Okay, that's good. So
We
yes,
should, sorry.
Yes, Steven?
Well, we should check the dictionary with that get so we don't get an error, key value error, before we actually do that. So that check before we actually start adding.
So check if the key is already in there. Yeah. And while we're doing this, so what they were saying was for the remotes that we need to check each number, and I think there was an iteration in there somewhere, and check if it is if that value in the array is already a key in the dictionary. So you could say iterate through array. If value is a key in dictionary, increase dictionary value by 1. And then what do we do if it's not a key in the dictionary?
Initialize it.
Mhm.
To 1.
Yeah. Else set dictionary value to 1. All right, and so we do that for every element in the array. And then we'll have a dictionary full of these key value, these like value number pairs essentially, right? Okay, great. So after that happens, then what do we want to do?
We look through each key in the dictionary for the largest key. That's our answer.
Yeah, so for the largest key, but there could also be more than one largest key, right?
So then we just create a new array, and every item that equals to that largest key gets pushed into that array.
All right, so we have an array that we can use. That'll be our return value. And then we iterate through our dictionary and check which one is the largest. If it is check which one is larger. If it is larger, we add it to our answer array. If it's not larger than the largest one already in the array, then we ignore it. Did I explain that correctly? I'm not sure. I feel like I kind of lost the thread there a bit when I was talking.
I don't think it has to be the largest one. I think it has to be equal to the largest.
Yeah, so greater than or less than or equal to, or greater than or equal to. Okay, so let's try it. So define, we'll call it return array. Iterate through dictionary. If dictionary value is, so we have, essentially we have three things that can happen here, right? Either it is greater than what's already defined as the largest, or it is less than, or then it's equal to. Because we're gonna, like, even though things are gonna be different depending on if it's greater than something or equal to something. Because if it's greater than something, that greater than we already have saved as the largest, we need to get rid of everything that's already been defined as the largest value. If it's equal to, we can just add it. But if it's less than, we need to ignore it. So let's start with, if it's greater than what is in return array, we need to clear return array and append value. If it's equal, then we just append it. And then at the end of it all, we just return the return array. All right, is this making sense to everybody? Does this seem like a good pseudocode solution to this? Okay. In that case, let's start making it happen. So first, we define the function. That step's gone. We need to define an empty dictionary. Simple enough. Then we need to iterate through our array. So we say for value in array. And we need to say if the value is in a key in the key in the dictionary. All right. What's the easiest way to check if it's there? Yes.
Sorry, we want to be careful about using dict because that is a constructor function or dictionary.
Perhaps it is. Do you have a suggestion?
I don't know.
Let's call it dictionary then.
Okay.
All right, so now what's a way we can use, how can we check if the value in the array is already a key in the dictionary or not?
Or
If value in key in dictionary, that works, right?
Yeah. So let's take a look at if we look at Python dictionary methods.
dictionary.get.
So dictionary.get returns the value of the specified key. So we can take a look at that if it decides to cooperate. So get mod, so we can, if we use get, it returns the value. And what, let's see, I don't know what it does if it doesn't find it, what it returns if it doesn't find it.
It returns the non-value or whatever type after what you're looking for.
Mm-hmm. Okay.
If you try to use the bracket notation for dictionary, if there's no key, you give a key error. And that will break.
All right.
All right, so
there's this default value, right, that you can specify.
Yeah, default.
So what Stephen was saying was that if we just said something like this, if dictionary value and there wasn't already there, we'd get an error and the code would break. So we could do something like this, dictionary.get value, which in that case will either return what we want or none, and none essentially evaluates to false in Python. So that will work. And I heard another one using if in. So we could also say if value in dictionary.keys. Both of these ways of doing it will work. And I wouldn't say that there is necessarily one better way in this case. It's just, two functions that end up doing the same thing. So That's one thing I like about Python, is that there's so many different ways to arrive at the same solution. So I'm just going to use this one because it's the last one I typed. So if the value is in dictionary keys, then we need to increase it by 1. You could say dictionary value plus equals 1. And then else, if it's not there, we just say dictionary value equals 1. So once this is done iterating, we should see all of a dictionary with all of these. And we can actually even check. So I'm just gonna have just a blank return statement, and I'm gonna run the tests. It actually shows us what gets things. So in this case, the test was for 1, 1, 2, 2. So 1 occurs twice, 2 occurs twice. And in this one, we have 1 instance of 1, 1 instance of 2, and 2 instances of 3. And here we have 1 is 1, 2 is 1, 3 is 1. They all occur equally. All right. So that all looks like it. That looks like it does its job. Before we continue on with this function, I want to talk with the rest of this challenge. I want to talk a little bit about kind of a coding philosophy type thing, because I'm a big believer that your code should be dry. Has anyone seen DRY, that acronym, before? What does it refer to?
Yourself.
Don't repeat yourself. And in this case, we're going to be fine. Our code won't repeat itself, but there may be other instances when we may need to find out what the values of everything in an array is again, something like that. And in order to make your code dry, it's important that your functions each do a single job. And the more you make sure that each function does a single job, the easier it is to do multiple things with them. Instead of, it's like, think of it as the difference between building something out of Lego blocks versus just, buying an action figure. If you build it out of Lego blocks, you can take it apart, put it back together in whatever shape you want. You can take Lego blocks from one set and use them in another set. You can do whatever you want with them. If you just buy an action figure, it's all glued together. So if we can make sure, if all of our functions do exactly one job, then we can have functions that we can reuse over and over and over again. Does that make any, is that clear? Is that analogy making any sense? Okay. So if we look at calculate mode, then what should calculate mode's job be? Yeah, to calculate the mode. Find out what the most frequently occurring element in this list is. And this is part of it, but that's not really the job of this function. So what we can do is we could make another function called find occurrences. I'm not sure if that's a great way to put it. Have it take
max occurrences.
What?
Max occurrences, because you're just trying to find out which one has the most.
Well, in this case, we're not trying to find out which has the most.
Okay,
all this function is
just
doing is just returning a dictionary.
Maybe you give it load dictionary.
Yeah.
This is what it does, right?
Yeah.
It pretty much loads our array into the dictionary.
Yeah, so we could do something like, or like array to dictionary. And I'm going to make this function, it just does all of this. And it's going to, instead of printing dictionary, we're going to return dictionary. We can remember how to spell it. And then here we just need to say dictionary equals array to dictionary array. Oops. Why is that going there? There we go. So now calculate mode still has all the same functionality it did earlier. If we run this thing, it still fails in exactly the same way. But now, all of that functionality of turning it into that dictionary with all the value occurrences now lives in this helper function. Yes?
Do you need to add the function array to dictionary into the spec file so that it can be imported too, or no?
Good question. Pavel was asking if we need to import this function here the same way we imported the calculate mode function. And because calculate mode calls on this, we don't need to. As far as Python's concerned, it'll go, okay, I'm going to import the calculate mode function. It goes here, finds calculate mode calls on this function, which is defined here. And this file doesn't need to know about it. This file will just, as long as this function works in this context, it'll also work when we import it. So that's a cool thing. So that's one way of, you can make these methods, these helper methods. They only need to be exposed as much as they need to be. So array to dictionary, as long as it does its job, calculate mode spec doesn't need to know anything about it. Any other questions about using this helper method and exporting it? Or I should say, what questions do you have about exporting it and defining helper functions? Okay.
Is that how we should be writing them kind of from here on out?
We've put everything to this helper function. We still have all that, so we still have all of this all done. So now we need to create a return array and iterate through our dictionary. Sorry, I just saw that my Slack went blank, so I'm hoping my internet connection's okay. Okay, I think we're good. That's going to be an empty array. And then we could say, oh, Brian had a question? Sorry, Brian.
Yeah, I was just asking.
Sorry, 1 second. The speaker's really low. I can't hear you.
Test.
There we go. Okay. Sorry, I didn't realize my volume was so down.
I was just wondering if you want us to write these helper functions kind of from here on out, if that's what we should be shooting for, or if we should just keep focusing on kind of getting to the solution however it is.
Mm-hmm. So I would say your first, my philosophy is get it working and then get it right in that order. So I split array to dictionary into a helper function after I already solved this once and realized, wait a second, this could be put out into its own helper method. So if in the process of coding you see a good place for a helper method, go ahead. But you shouldn't necessarily, don't feel like you absolutely have to do it the first time around. If this is something you don't really think about until it's time to refactor the solution, that's also fine. But I would keep this in mind as you're going through your problems from now on, and just be on the lookout for saying, okay, if my function's job is X, but I need to do Y in order to do X, could that be a helper function? So I like to see that, but first focus on getting it working. And the more you do it, the more you go back and refactor things that way, the more those opportunities will become obvious to you, because you'll start to notice the patterns of where helper functions can help you. Does that answer your question, Brian?
Yeah, it does. I mean, because I've already noticed I've been using code from previous challenges on challenges in the future, and doing something like that I think would help out a lot.
Exactly. Good.
Just when you get your jobs, when you're working on your application or whatever code base you're on that has like hundreds of thousands of lines of code, helper functions are generally broken out into separate files. Like the file might actually be just called helper function, and that file will have a bunch of helper functions, a little line of like commented on code of what that helper function does, and that file will be imported into whatever other file or part of the application that needs that specific function.
Mm-hmm. Remotes, did you hear that? Yep.
So I had a question. If you separate the helper functions in different files, like Tom was describing, in your main function, would you do the import there?
Correct. You import the helper function into that calculate mode.
Yeah.
Okay. Gotcha.
So I could have said something like this, from helpers import array to dictionary or something like that.
But for your challenges, you don't need to do that. Like, you don't need to create a totally separate file just because from a scalability perspective, it's only like 1 or 2 files tops.
Yeah. If it's just you have like 1 or 2 or even 3 helper functions, might as well keep them all in one file. Any other questions on helper functions before we move on?
Would you keep helper functions at the beginning or end of the code?
For Python, it doesn't really matter. I think in general, it should be okay. The order doesn't matter. I think most people put them afterwards, but
In JavaScript, if you call the function before it's declared, it will throw an error.
yeah, that's true. Yeah, so in JavaScript, I think you need to define the function first. But Python, actually, I'm going to try. I'd like to. Yeah, actually, we can test that out. If I do just call and calculate mode here before we define the function, let's see what happens. So if I do Python calculate mode. Okay. So in this particular case, I called calculate mode here before array to dictionary was defined, and it said array to dictionary is not defined. But it doesn't matter when I do it here, because when this import statement doesn't actually run any code, it just gets everything. So in this case, it just kind of depends on how it's defined. If I'm calling on the function before a helper function is defined, in this particular instance, literally before it's defined in the document, that's one thing. But if I'm exporting it to a spec file, the order doesn't matter, because the entire document is compiled first. Okay. In that case, all right, I'm going to start iterating through my dictionary. Then I'm going to say for key in dictionary. Because when you iterate through a dictionary like this, it'll automatically iterate through the keys. So I could do for key in dictionary dot keys, and it would do the exact same thing. All right, so in this case, so I'm iterating through, and I want to check if the dictionary value for this key is greater than what's in the return array. Question though, what if there's nothing in the return array?
What I did, I just created a variable I, and then I just set I to 0, and then the very first key pushes that I to the value of the first key, and then you just go down line by line, or every item in the dictionary sees if it's equal to or greater than I.
Mm-hmm. Yeah, so that's one way to do it. We could have something in the return array that's set to 0. Is that right?
No, I just created a variable before I iterated through the dictionary.
So a variable that you set like this?
Yes. And then if key is greater than 0,
mm-hmm.
I would push the I to equal that key. Or if key is greater than I, then I use that key. And that way I know what my greatest value is.
Oh.
Or at least that's how I did it.
So
it would never be empty because you made sure it wasn't empty?
It was, if it's
so
empty,
you're not,
it's irrelevant.
So Pavel created this variable I, which keeps track of what the greatest value is.
That's correct.
And so that's what you compare rather than whatever's in the array. Oh yeah, that could work.
That's how I think.
Or we could use sorted, right? Sorted with a key of lambda and value.
Yeah, so we could also use a lambda and sort our dictionary. That's one way to do it as well. I'm going to try Pavel's solution here because, I don't know, I hadn't actually even thought of that. Because what I did when I went through this is I literally just said, if length of return array is greater than 0, then put everything inside of that. But if we have something right here, I'm going to name this variable something a little more descriptive. Yeah, so I could just do, you know, highest equals 0. So then I can just say if dictionary key is greater than highest. I want to set highest is equal to dictionary key. And then I want to clear out the return array of anything that's in it.
But I don't think you added anything to the return array in the first place, since there's nothing in it from line 3.
Nothing in it yet, but there might be as we iterate through the function. Because if it's like 1, 1, 2, 2, 3, 3, 3, 3, 3, then 1 and 2 will be in the function when it gets there.
I don't really see that, but I think you could also just remove line 3, line 8, and line 9 at this level, because you would just look for the most frequent key. You're not get.
But there may be more than one.
Yeah, but they will all have the same value of highest.
Yes, but so the return values we're looking for are which elements occur the most frequently. Yes?
Oh, yeah, you're correct. You're correct.
And it has to be an array. That's what, even if there's only one of them.
You're correct. Okay.
So I'm going to append key. All right, and then if dictionary, we need an elif. If it's equal to the highest, so it's not dictionary key equal to highest, we don't need to change what highest is, but we do need to append it to the return array. And if it's not greater than or equal to that, we just ignore it.
Wouldn't you also clear the return array on line 9? You create another line to clear the return array.
Here? Well,
yeah, if you had another line on that.
I think we only need to clear it if we found a new highest value. So we need to get rid of everything that was lower than that and then append a new one. Once it's done that, then we can just keep on going until we find a new highest one, right? Okay. Does that make sense? All right. So then I'm going to, at the end, I'm going to return array. So kind of iterating, talking about the solution again. So we have our return array. We have a variable that keeps track of the highest, not the most occurrences. We loop through our dictionary. If the occurrence number is greater than this, then we set this equal to that value. We clear out return array of anything that was already in it, and then we add the new key. If it's equal to that, we just add it to there. And then at the end, we return the return array. And we can check our test file, test spec, to make sure. Ran 3 tests, all come out okay. I keep on forgetting to use green instead of that, but yes. Cool. All right, what questions do you have about the solution now that we have passed all our tests? Okay, cool. So let's see here. It's 8:40. I don't want to take a break just yet, but I'm not sure if we have time to really get way into, well, pattern array probably won't take too that long. So let's press on to pattern array, then we'll take a break, and then we'll move on to balance brackets. Sound good?
Can you put the last one up for just 5 more seconds?
Sorry, to put what up?
What we just had? Yeah, okay.
Okay, cool. So I'm gonna look at pat array. All right, so this is another one we can do in Python or JavaScript. Any?
Let's do JavaScript.
Okay. We'll do it in JavaScript. All right, so we look at pattern array. Let's see what we're actually trying to solve here. So we have a write a method called pad. It'll accept a list, a minimum size, which is a non-negative integer for the list, and an optional argument of what the list should be padded with. If the list length is less than the minimum size, pad should return a new list with the pad values up to the minimum size. So if we give pad an array of 1, 2, 3 and a minimum size of 5, we get 1, 2, 3, none, and none to make it 5 length. This is a Python example. And if we give it that extra argument of apple, we get 1, 2, 3, apple, apple. If the minimum size is less than the actual size of the list, then we just return the list. Does anyone have any questions about what we're actually trying to accomplish here? Is it all making sense? Or is it a little weird? I know it's one of those things where sometimes the explanation is a little bit odd, so. Okay, so we can quickly try to get some unit tests going. Let's take a look at jest again, because it's always a little weird. So let's just follow the instructions, npm install -- save dev jest. Let's make sure we go into our JS file. Can't really see what I'm typing. There we go. Did anyone get any new insight into jest over the weekend?
What exactly does it do again? Just.
So jest is a suite of unit testing software that we can get, and it is just a way of automating tests the same way that unit test does. So instead of writing console.log this equals this, we write these tests that are more descriptive and can tell us exactly why something fails and where.
I'm still confused about why it's deep and like it's giving like do you want to use deep comparison or you know what I mean? Like some of them to be equal or to exactly some of them is like
yeah.
Are you using deep equality instead of shallow equality?
Yeah. So the more nested data. So he was asking about deep, like what deep equals means. And in this case, what we're talking about is often the more you get into web development, you'll find extremely nested data structures. So arrays within hashes, within dictionaries, often getting nested very, very deeply. And if you just check what those equals are, it'll only do it at a very shallow level, like at the top level. And if you want to check what something is equal to more deeply, then you need to use functions like that. And those are kind of recursive functions that check everything inside this nested structure. So at this point, we don't really need to worry about it too much, but as we get on into things like JSON, we're going to have to worry more about whether checking if things are deeply equal.
Because it kept giving like sometimes you could ask, do you want to use
Can you go up one line, please? I just want to see that install statement again.
npm install -- save dev jest.
Okay.
As you can see, that gave us a package lock.json and a whole thing of node modules, which we don't really don't really need. So when we're using our get, we may want to add that to a get ignore or something like that. All right, so if we look here, the unit tests aren't set up yet. We have pad array is already set up. That's good. So we look at pad array spec. We can take a look at this. So the way jest works, its syntax is we say test, then we have what it's supposed to do, then a fat arrow function, then we expect one thing to be something else. So we can write a test for that right now. So we can say, first we need to import it. So if I take a look, So pad, we need to make sure that we export this. So we could say module.exports equals pad. And then we can say const pad equals require pad. Equals require / pad array. So by saying we said module.exports equals pad, we're exporting this function, and this one's functioning it, it's importing it from our other function and saving it to this variable. So now the pad function here is equal to this pad function. So we can say test pads an array with null. Get our fat arrow function. Also, I gotta say, I love fat arrow functions. They didn't exist when I was first learning JavaScript. They make your life so much easier. Because otherwise you have to write test this function, blah, blah, blah. This is a lot better. Let's expect pad 1, 2, 3 with no other argument, with the argument of 5. Dot to b 1, 2, 3 null null.
What's the difference between 2b and 2 equal?
Let's take a look. We take a look. They have their using matchers here. Let's see if they can tell us. So .2b says with exact equality is the word they use. And then let's see, do they have two?
So is it like 2 versus 3 equals?
Yes, it's a lot like that. So .2b is like 3 equal signs, and .2 equal would be the same as 2 equal signs, I believe. So .2b, usually you'll just want to use that. And then we could have another one. So test heads an array with the optional argument. Oops. There we go. We expect pad 1, 2, 3, 5, and apple. Oops, I didn't give it a parentheses after pad. There we go. .2b, 1, 2, 3, apple, apple. And then let's do one more, test returns array if minimum size is less or equal to array size. Keep on doing that. Also, just making it look nicer. It'll still work even if you don't have that space there, but I like my JavaScript to look nice. So if I just give it 1, 2, and 3, the extra argument of 3, should just be 1, 2, and 3. All right, so now we should be able to just say npm run test, I believe is the command. Okay, so we got some errors. So it says no such file or directory open. So it doesn't have a package.json, but it must have been looking for one. And if we look right here, it says add the following section to your package.json, this. And we've got a package lock.json, but not a package.json. We can fix that. So we can make a new file, call it package.json. And we can just copy this, put it there.
Oh, so I was copying and pasting. It was those two lines plus the line dependencies and just caret 24.9.0. Are those next two lines irrelevant?
Which next two lines, sorry?
I don't know how to explain this easily. So I had 4 lines that I was just copying into a package.json file that I was making. It was scripts, test jest, then dependencies, and just 24.9.0.
Okay, where did you get those particular lines? I'm just curious.
I thought it was what we were adding to our files yesterday or last class.
Yeah, I'm not super sure, to be honest. I'm just following what they say on the things. Tom, do you have any insight into that?
Like, it'd still work if you literally just create a touch package.json and like that script in there.
Mhm.
But if you really like, it's better to just do npm and go with all that.
So yeah, using npm init is probably the better way to do it. But anyway, if I run the test right now, it says run with no test found, exiting with code 1. Ah, okay. And it tells us what we did wrong here. Test match, spec test. So remember what I was saying earlier about how sometimes you need to make sure that your files are named a certain way? Yeah, so just looks for something that's called padarray.test.js, and we didn't do that. So I can just rename this to, and I get little icon changes. Okay, so we're still getting these NPM errors, but they're not actually failing anything. And we have test suites, we failed all of them. It's great. Also just realized it's 53, so let's say we take a break, come back at, let's say, 9:03. We'll finish up with pad array and then move on to balanced parentheses.